Thank you for all your presentations. I'm Karthik Ramani. I'm a professor here in ME, and it turns out I started this class in the 90s, but also inspired by one of our alma mater, Don Feddersen. And Don was visionary CEO of a company called Applicon and many others, and pretty much started a lot of the early CAD/CAM revolution, and also was the person behind Creo, the PTC software that you guys are using. So in that light, we have 3 visitors today. So you can come up front here. Jordan Cox, he's Senior VP at PTC. And then we have Alisa and Nathaniel also joining us. So you can say a few words, and you're seeing all your software really mixed up here.
Yeah, this is great. No, excited to see how you're using our software. We have some new exciting things coming out. So you won't see it this semester, but the next semesters we'll start to see we have an integration with ANSYS, so that now instead of building your models and passing it off to do a stress analysis, the stress analysis is integrated into the modeling. So as you model, you'll see the stress analysis changing. So that's pretty exciting. Also in Creo 4.0, we have augmented reality built in. So you take your model, you put a thing mark in relation to it, and you hit publish, and boom, you can get it, on your phone or whatever. You can hold it out there and see it in augmented reality. So those are coming. We're pretty excited to see the work that you do here. You were one of our first universities to use Creo. I'm in charge of the academic program at PTC. We work with about 2,000 universities worldwide. So I have a team of international people in Japan, Russia, China, India, and Europe. They're all working with universities to get the software into classes like these. So really happy to be here. I actually graduated from Purdue in 1991 with my PhD, and really fun to come back home. Boiler up. Thanks.
No, I'll just leave it here.
Hi, today we will be presenting our toy, the Ultimate Fidget Cube Purdue Edition. I'm Delaney Sunbury.
I'm Gabe. I'm Rohit Srivastava.
I'm Joe Biada.
So first, a little overview of our presentation. First, our project background and kind of the inspiration behind our toy. Toy description, we're going to highlight some of the cool features in our toy. Then we'll describe our 2 non-trivial motions inside the toy, and then we'll be demonstrating it. So what is a fidget device? So fidget devices were designed to help people with anxiety, autism, or ADHD kind of stay focused in class. It's something to do with your hands while you're trying to pay attention. Right there is a fidget cube, so each side of the cube has a different kind of small activity to do. And then the fidget spinners just spin. Now they're very popular in all children.
So our project objectives were to create a toy that would sort of fit the Purdue theme and associate itself with the 150 years anniversary sort of theme that's going on this year, and supply children with various activities to do on large faces that we have here. So here are just a few pictures before we go into the toy description. So there are 6 unique faces. The front is a fidget spinner that is Purdue themed with hammers. The right side is a Scotch yoke where Purdue Pete bobs his head up and down. The left side face is the 150 years lever that you can push back and forth. The back is a Purdue maze that lights up when you put a ball in the middle if you're just playing around with like one of those mazes. And then there's a driving mechanism at the bottom which can lower itself. So here's an animation that we prepared, at least nothing work. So that's how the fidget spinner spins.
So we took the bearings off of an actual fidget spinner and used them in the harness.
And that's how Purdue heat bobs up and down after there's a Scotch Egg on the inside. Yeah. This doesn't work in Rio, obviously. And there's the lever that pushes the 1 and 0 back and forth. There's a driving mechanism.
Now I'll talk about we're going to talk about some of the mechanisms, the non-trivial mechanisms we actually implemented. The first one is the 150 face, as you can see here. And the idea of it is that there's just a simple linkage here, and the 5 is stationary attached to the outside of the base, whereas the 1 and the 0 you can push back and forth for essentially mindless entertainment. And that was kind of the original inspiration for our design, was something that you could just play with mindlessly, and push buttons were one of the first things we thought of. And so this is kind of just in general what the mechanism is. You push one down, the other one comes up, and then vice versa. And then we'll show you the smooth mechanism of action, the one that works perfectly in simulation, obviously. And then also so you can see the bottom linkages moving. Now, Joey will talk specifically about the Scotch yoke mechanism.
Yeah, so the Scotch yoke mechanism that we built has a wheel rotation device. So you basically take this wheel rotation device and you move it around in a circle. There are two linkages connect to the wheels, one on the front and one on the back. We did this to make the wheels rotate smoothly. With only one in the front, they wouldn't really work too well, and sometimes the wheels would get messed up to where one was going one direction, one was going the other direction. On the back, there is a Scotch yoke mechanism. So when the pin gets to the very top, Purdue Pete's head will be shown in the train. But when it's at the very bottom, then Purdue Pete's head will disappear. One of the very last things that we actually added was a yoke support collar, because it wouldn't, the Scotch yoke would actually not stay parallel to the base, and that would cause a lot of problems. And when you do rotate the head, when it comes down, you actually get a little IU sucks thing in there, kind of reminding Purdue students and faculty who the real enemy is. And so that is, so before we move on to the next thing, well, actually this will show a little bit of demonstration on what happens in behind the cube. When the wheel rotates at the very bottom, his head goes down, but at the very top, then his head pops up. Okay, so before we move on to any questions or anything like that, we're going to present the toy.
So the front face is the fidget spinner. It has 3 hammers, and each one has a Purdue written on the inside. What we did is we took apart a real fidget spinner to get the bearings, and so that allows it to spin as freely as any normal fidget spinner would.
So like I just showed, you have the Scotch yoke mechanism. You take this lever and you rotate it around. So Purdue's head comes up and down.
And then right now, this usually has a cover on it, but just for demonstration, we took it off. But it's a maze. It has a small little ball, and you kind of move the maze around to make it go through. The goal is to get it right here in the center, which will complete the circuit, and then it lights up.
You could try that come up and try it afterwards if you would like.
And then the 150 face, where you can simply just press the buttons back and forth, and they'll do that forever.
And the drive face, so you have to,
There's a crank on the top.
there's a crank on the top, and then you lower it down. This takes a while. But I don't know if you guys can see that. Maybe turn it this way a little bit, but you can see like the wheels sort of coming out now. And then flip the switch, and you can drive it.
So you can either drive it around, you can push it around, or do whatever you would like with it. So that is our cube. Do you guys have any questions? Tom?
Is it, as far as driving it around, do you control it like through your phone again using Blink or?
Yeah, that would that was the idea behind it.
So yeah, ideally, yes, but there's a lot of weight on the cube, so, and the motors we use are the same motors that we had from the previous project, so everything is just sort of over-torqued and can't really move.
So as far as future improvements go, we would definitely try to find a little lighter weight of material and kind of make that a little bit smaller and find a motor and a servo motor with a lot larger torque.
What was the hardest part in designing and then building it?
So as far as the Scotch Egg goes, there are a bunch of parts that definitely when you design them, they were very nice, but when you fabricated them, sometimes the parts were too thin to where they couldn't actually hold up to any force that was being applied to them or anything that we needed to do. So as far as mine goes, I had a decent amount of my parts break. But the nice part about that face is that it's all 3D printed, so you end up making the parts larger, but it didn't end up work just from 3D printing.
The assembly was also rather difficult. Since all of our faces individually we were able to get completed, but as far as actually getting all 6 of them together, you couldn't test it or put it together until all 6 of the faces were fully functional, and so that took a lot of time to get to that phase and then actually testing, which is where we ran into the issues with the motor. Yes.
You guys mentioned that it's really heavy. Would that deter you from playing the maze game? Because I know you said you would like want to do a topsy-turvy kind of thing. Is that kind of
Well,
what
you get like a workout in the process, right?
It's not too heavy, but it's heavy enough that since we didn't quite have enough time to look for a more powerful motor and design a proper gear ratio, and that one's rather weak, then it's not able to do the full box. But as far as like holding it in your hand, it's not easy.
Okay.
Yes.
Do you have like a photo of the inside of the box that you can show me later?
Actually,
Yes,
yes,
we do, actually.
Actually, yes, we do.
I'd like to see that.
Yes, where you go?
Did you consider scaling it down at all to make it more feasible to hold it and bring it with you?
So the main reason that also I think similar to the previous group that mentioned is that we made it larger was that especially for which we found out for the Scotch yoke, making it larger allowed us to make the mechanisms bigger, and so they're simpler and more robust. But if we were to actually make it into a full toy, we would change some of the fabrication methods, I think, on the actual product and then shrink it.
Yeah, probably make it about 4.5 inches by 4.5 inches, not 9 by 9.
Maybe.
How did you model that? How do you repeat this?
I thought similar to, so I ended up modeling that one, and I thought similar to kind of how actual reconstruction software works. I just designed, I pulled up a model and visual, and I designed a bunch of blends. And so I kind of sliced it into 7 sections and then blended them together to create the actual face.
The fun part about designing this was that we actually got to apply a lot of things we learned in class, the Scotch yoke, some of the sweeps and blends and things like that. We kind of found